I'm Molly Minky. My students call me Dr. Minky, and I get to teach here at Pima Community College. I actually get to teach math, but today I get to share with you one of my passions, which is physics. My undergraduate degree is actually in physics, okay? Because physics is what? It's math in motion, and I thought it was cool when things were moving. All right, I then got a PhD. And my PhD is in materials science and engineering. But as I said, I get to go back to my roots and do some physics today. So we're going to talk about energy and energy transferring. Okay? So if you think about it, when you went to school this morning, you either got in your mom and dad's car or maybe you got on the school bus. But what did they do? They pushed the gas pedal and it started moving. So you have the gas coming in, which is a chemical. It releases energy. It's a little mini explosion, but it releases energy, and that then transfers to kinetic energy, how our wheels turn on the car. So when you go home, you can go, the minute they step on the gas, you can go, Mom, you just caused an explosion. See if you can freak her out with doing that. All right? So real quick, before we get to our fun little experiment, I'm going to have you guys do a transference of energy. So put your hands out together. And we're going to smack them together, and then we're going to rub, 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 rub. Rub, keep rubbing, rub faster, rub faster, rub faster, rub faster, rub faster, rub faster. And wow, are your hands a little warm? Might even look a little red. Okay, what happened there? We took our kinetic energy and moving it back and forth. Kinetic energy is energy moving. And when we rubbed our hands together, we created thermal energy, didn't we? Right? So, another example of that has to do with gravity. Gravity is why we don't go flying away. All right? It keeps our feet on the ground. If I'm holding this here, that's potential energy. The minute I let go, it's kinetic. So as its potential energy lowers, its kinetic energy is going to increase. The total energy is called mechanical energy, and that's always going to be the same. But potential energy is just like you, where you have potential to be a great scientist. Kinetic energy is for you doing your homework and actually becoming a great scientist. Okay, so we're going to look at a pendulum. Physics people love pendulums. When you guys take your college level physics class, you'll spend a lot of time doing pendulums, okay? Because we don't have a lot of friction going on. So it's a way we can model things, do some math, where we're not like our hands, those were friction. This isn't going to slide against anything. So it therefore is not friction. All right, so we're going to look at how we can transfer energy between those pendulums. So here is our pendulum setup. We're going to spend some time playing with some pendulums. And physics people love pendulums. When you take your physics classes in high school and college, you're going to spend a lot of time looking at pendulums because it's friction-free. When we rubbed our hands together, right, there was friction. So a couple of things about the pendulum. We have a bar, we have a string, and then this, you could do this at home. My husband and I remodeled a kitchen, and these are just the handles off old kitchen doors. All right, so with our pendulum, the length of the string actually makes a difference because the length of our string gives us frequency. All right, and so what's frequency? Well, it's one going forward, back, forward, right? It's that one type of scenario. So I'm going to pull this one back. And notice, he's off the ground. If we would draw a force on him, it'd point straight down because that's gravity. So that's his potential energy as I'm holding him back. When I release him, his potential energy is then going to turn into kinetic energy. So you can see he's swinging back and forth. That is now, he is experiencing his kinetic energy. All right, now we're going to look at these two pendulums. They're basically pendulums. They are connected here at the top, and that's going to become important in a moment. But I'm going to start. What happens if I give both of these pendulums the same kinetic energy? Or I'm sorry, I made a mistake. Did you catch it? Did you catch it? What type of energy is this? It's potential energy, right? It's not moving yet. It's potential energy. So I'm going to pull them back, and we're going to let them go. And notice, they both move somewhat together, don't they? I probably didn't release them together. So that's an experimental error on my part, but they're both moving together. Okay, now in the beginning, we talked about how energy transfers, and that's what we're going to see here. We're going to see energy transferring, so I'm going to stop them. All right, I'm going to leave this one. He's going to stay in the rest position. Physicists love to call this T-naught, right? It's its starting position. So when you go to your physics classes and you hear them talk about T-naught, they just mean where things are starting. This pendulum, I'm going to pull back. So I'm only giving one pendulum potential energy. Now let's see what happens. I'm going to let it go, and here comes his kinetic energy. All right, and would you look at that? The second one starts moving. He's sharing with his friend. Now, the first one's come at rest, but the second pendulum now has the kinetic energy. Now look, they're sharing back. All right, so this one here is now back at rest, and this guy here, he's still moving, isn't he? So they're translating energy back and forth between each other. So what did we learn today? Well, we learned that energy transfers. And like we saw with the pendulum, energy of one gave it to the second one, and then it gave it back, right? So when we do this, what are you going to do this afternoon? The minute your mom steps on the gas on the car, you're going to say, "Mom, you just called an energy transfer. You caused an explosion." The gas, the chemical, right? It turned around, it did what? Made a little explosion, caused your wheel to turn, and it became then kinetic energy. One last thing. Potential energy doesn't move. It's getting ready. It's our ready energy. Kinetic energy is when we're moving. It's our go energy. Thank you for spending time with me here today. I hope to see you all at Pima Community College in the future. I teach a lot of the calculus classes, so come on over to Pima and visit me in calculus. Bye now.